Welcome to Tabo Eminent Channel. If quark stars exist, they might be around 9 kilometers, 5.5 miles in diameter and a bit more than twice as massive as the Sun. Otherwise, neutron stars are the smallest, around 10 kilometers, 6 miles in diameter, and can be between 1.4 and 2 times as massive as the Sun. Stars more than 8 times as massive as the Sun explode as supernovas in their advanced age. They leave behind neutron stars or black holes. Neutron stars are composed of neutrons because very high pressure due to immense gravity causes protons to merge with electrons. Thanks for watching. Request you to subscribe the channel. Our Milky Way galaxy of 200 to 400 billion stars contains about a billion neutron stars. Some rotate very fast together with powerful magnetic fields, and they beam radiation from their poles. These jets sweep through space like lighthouses, and when they reach Earth, we register pulses from them. These are pulsars. Some neutron stars have extraordinarily strong magnetic fields and are called magnetars. Neutron stars at the top limit of their mass before they usually collapse into black holes might instead be quark stars. Perhaps at that very high pressure, due to even stronger gravity, neutrons in them dissolve into quark matter. Neutron stars are already tiny at around 10 kilometers, 6 miles across, but quark stars might be as small as only 9 kilometers, 5.5 miles in diameter. Some known neutron stars are theorized to be quark stars, but this is not yet confirmed. The least massive stars are brown dwarfs, whose mass starts from about 13 times the mass of Jupiter and is usually only a bit larger than this planet. We found some that are smaller, though. They are not massive enough for nuclear fusion of the protium isotope of hydrogen, which has only one proton and no neutrons in its nucleus, to occur in them. Instead, their faint brightness and low temperature, which can be even just room temperature, come from the nuclear fusion of deuterium. Red dwarf stars are the tiniest regular stars in which the nuclear fusion of protium can occur. Their mass starts from about 80 times the mass of Jupiter. The smallest known one is the size of Saturn and 85 times as massive as Jupiter. It is called EBLM J0555-57A and is 670 light-years away from Earth. The smallest known star in the Milky Way, EBLM J0555-57A, is an extraordinary object that challenges our perception of what stars can be. Discovered by astronomers using data from the EBLM, Eclipsing Binary Low Mass project, this star is located about 600 light-years away from Earth. What makes it so remarkable is not only its diminutive size, comparable to that of Saturn, but also the fact that it still manages to sustain hydrogen fusion in its core, the fundamental process that defines a star. EBLM J0555-57A is part of a binary system, orbiting a larger companion star. It was found during a survey of stars that eclipse one another from Earth's perspective, which allowed scientists to measure its size and mass accurately. With a mass roughly 85 times that of Jupiter, it hovers just above the threshold that separates true stars from brown dwarfs, the so-called failed stars, that are not massive enough to ignite fusion. Its radius is only about 0.084 times that of the Sun, making it one of the tiniest fully fledged stars ever discovered. Despite its tiny size, this star still shines, albeit faintly, due to the ongoing fusion reactions in its core. Its discovery has deepened our understanding of how small a star can be while still undergoing fusion. It also provides insight into how low-mass stars form and evolve, as well as the nature of exoplanet systems, since stars like EBLM J0555-57A could easily be mistaken for large planets without precise measurements. EBLM J0555-57A may be tiny, but its story is immense in terms of scientific impact. Astronomers discovered it as part of a survey that was initially focused on finding large planets. Using telescopes in Chile as part of the Wide-Angle Search for Planets (WASP) project, scientists noticed something intriguing: a faint dimming of a larger star caused by an orbiting companion. At first, they thought it might be a planet, but further analysis revealed it was actually a star, just an extremely small one. This moment of realization was thrilling for researchers, as they had stumbled upon one of the most extreme examples of stellar minimalism ever recorded. What's fascinating is how this minuscule star still qualifies as a true star. To be considered a star, an object must be massive enough to sustain nuclear fusion of hydrogen into helium in its core. That minimum mass is about 0.075 times that of our Sun, right around where EBLM J0555-57A flat sits. Below that threshold, objects become brown dwarfs, which glow faintly due to residual heat but never ignite into full-blown starlight. EBLM J0555-57A flat walks the razor's edge of this boundary, proving just how efficient and compact nature can be when forming stars. Because of its tiny size and low brightness, this star would be completely invisible to the naked eye or even to many telescopes. Only through the precision techniques of eclipsing binary observation, where astronomers watch how one star dims as another passes in front of it, could its size and mass be revealed. This method allowed researchers to not only confirm it was a star but also to calculate its mass, radius, and orbit with surprising accuracy. It orbits its larger companion every 7.8 days, and their relationship resembles that of a planet orbiting a sun, making it an ideal test case for studying compact binary systems. The discovery of such a tiny star reminds us that the universe still holds many surprises. Objects like EBLM J0555-57A flat challenge our assumptions and expand the boundaries of what we know about star formation and the lower limits of stellar mass. In a galaxy filled with giants, it's often the smallest players that reveal the most intriguing secrets. Though EBLM J0555-57A flat is among the smallest stars ever found, its story is a powerful example of how far astronomy has come in detecting and understanding the faintest objects in our galaxy. Stars this small are incredibly difficult to find, not only because of their weak light, but also because their small size means they can easily be mistaken for gas giant planets. Before we had the tools and techniques available today, such an object would have gone unnoticed. It took a combination of careful observation, advanced modeling, and lucky alignment, where the star passed directly in front of its companion from our point of view, for scientists to uncover it. What makes EBLM J0555-57A flat even more interesting is the idea of what a planetary system around it might look like. If this star had planets, they would have to orbit very close to stay warm, given its limited heat and light output. Such worlds might be tidally locked, with one side always facing the star, baking under constant light, while the other side remains frozen in darkness. Life, if it could exist in such conditions, would have to adapt to extreme environments, yet, theoretically, it's not impossible. Astrobiologists often wonder if small stars like this one could harbor Earth-sized planets in their habitable zones, and discoveries like EBLM J0555-57A flat help refine those theories. In addition, this star plays a crucial role in refining our understanding of stellar evolution. Stars at this lower limit of mass live for incredibly long periods, trillions of years, far longer than the current age of the universe. That means EBLM J0555-57A flat and others like it are practically eternal by human standards. Unlike larger stars that burn quickly and die in dramatic explosions, tiny red dwarfs like this one are slow burning and incredibly stable. It's possible that in the distant future, when all the larger stars have long since burned out, red dwarfs like EBLM J0555-57A flat will be the last stars shining in the cosmos. Even though it's smaller than many planets and gives off just a whisper of light compared to the Sun, EBLM J0555-57A flat tells a rich and exciting story about the diversity and mystery of stars in our galaxy. It stands as a testament to how even the smallest celestial bodies can offer the biggest scientific insights.